Um, this is my infographic about my history. So I spent a long time at Oracle. I've been part of the Oracle community since 1989. Written a couple of books. It looks like four, but the three up on the top right are these three here are three different editions of the same book. But the book keeps getting thicker and thicker, so it's about 300 pages now. I represent a company called Method R Corporation. I've run this thing since April 1st of 2008. We really do three things. We do consulting, training, and software, and we're mostly software developers. So everything really that we do hinges around that. If you want to contact us, you can reach me personally at info@methodr.com, or you can take a picture of this QR code. I'll show the QR code a couple more times as we go. I have a special offer that I can talk about today. There's kind of our way of trying to help during this COVID-19 pandemic. We're teaming up with Sintra Software and Services, who I still have a close relationship with. They're offering a 90-day program where you can learn how to use Method R and our Method R Workbench application for free. It'll consist of weekly 1.5-hour sessions that I will conduct personally. If you're a Workbench customer, it's a great opportunity to brush up on what you can do with it. If you're not a Method R Workbench customer, that's our product, then our partner at Sintra will provide a limited license for you. So you'll be able to do all the things that I'm going to show today. So I'm going to take a little more freedom to show you some more stuff you can do, because you don't have to buy anything to do it. So again, if you're interested in the program, contact me directly. Either hit methodr.com, info@methodr.com. The only trick is that there's a hyphen in our URL, or you can, like I said, I've paused long enough. If you want to hit the QR code, you probably already have. So on to today's lesson. Today's lesson is really about this. You really can trace everything. Now, when I say that, I can probably predict what you're thinking. You're probably thinking, won't that slow everything down so badly that I would never want to do that? And maybe the thing you're thinking is, why would I ever want to do that? And so let's tackle the first one first, so you can break through the disbelief, I guess, and then we'll have some fun exploring what we can do with it. And Ed, I don't know if the video is really helping anything. So at this point, I'm thinking if you can turn my video off, it may help with the bandwidth, because there's not going to be a whole lot of stuff that I need to do with my hands or whatever. So that's up to you. And I don't know why I said Ed, but I think it's because I looked up and saw his name. All right. So you really can't trace everything. Want to slow everything down. Let's talk about that first. And that's lesson one. It really is okay to trace everything. And that's because tracing is unnoticeable if you do it right. The thing is that application durations naturally fluctuate more than 5% plus or minus. And to give you an example, you wouldn't think twice about it if an hour-long report sometimes takes 57 minutes and sometimes 63 minutes. You may not even care if it runs 45 or 75 minutes. It's still kind of your hour-long report. Well, that's enough to mask the impact of tracing if you do it right. And I'll talk about doing it right here in a moment too. But this is not just theoretical information. This is data that we've measured carefully in the field. We have one client that actually traces everything in production, a database-wide trace. Sometimes they trace their whole entire production system for 6 hours at a time. And these guys are a very, very large company. They track response times precisely with a tool called Dynatrace, which is a very famous application measurement software package. It's very expensive and very detail oriented. So they track every response time of everything that everybody does on their system, and they have measured that with tracing turned on correctly, there's no measurement intrusion to speak of. Nobody has ever noticed at this customer that tracing is degrading their performance in any way, even though they measure it carefully. So it is very important, though, to do it right. And that's because of this imperative. You never want anybody to believe, whether it's fair or not, that tracing is hurting your business. Because when that happens, people start to build up an immunity, and it takes the tool away from you. Kind of the worst case scenario is if you make some kind of mistake that causes people to think, oh, that tracing thing, yeah, we did that once, and we're never going to do that again. We want to stay diametrically opposed to that kind of philosophy. What you want is for people to go freely to suggest, yeah, let's trace it. It's running a little slower than we expected, or I'm just curious what's going on in there. Let's trace it. You want tracing to be this thing that's it's a positive, that's never going to conjure up some kind of a ill feeling. So how do you do it right? And the first thing I'll say to this comes with a picture. I want you to create an emergency trace disable feature that works immediately. Because if anything ever does happen, or if anybody even perceives that something is wrong, you want to be able to pull the ejection seat handle and stop the trace. I'll give you a quick anecdote. Imagine that tracing has nothing to do with it, but some program happens to run more slowly because a developer added a feature to it. But it just happens to be running for the first time on a day when you decide you want to try to trace some things. There's going to be no stopping the perceived cause-effect relationship between this program, which today is running slowly for the first time, but because the developer changed it yesterday, and tracing, which we've never done before. And if something like that happens, it's really, really hard to wash that out of people's minds. So number one, create an emergency trace disable feature that works immediately. So you have this option of just shutting it down without affecting anybody from there on. Number two, and this is just common sense really, is respect the IOs per second capacity of your storage. Because the one thing that tracing can hurt you with is if it does so many writes to a low IOPS capacity device, then you can start waiting on the IO to that device. Same applies to the storage capacity as well, because you don't want to fill up your diagnostic desk directory, because that's where the alert.log file is written. And if alert.log can't get written, it hangs your instance. So you need to be very careful about the IO, both the IOPS, as I say on the slide, and the storage capacity. Mary Elizabeth, if you wouldn't mind, would you make a note that on page 10, I need to add the storage capacity as well? If you're listening carefully, I'd appreciate if you do that. Slide 10. The next thing you need to make sure of is that you're tracing at the right level. We'll talk about that in a moment. And then finally, test. You never want to turn trace on, just like you never want to create a feature in production without having tested it first. So you want to test. How do you turn it on? Does it really do what you expect? Does it fill up space faster than you expect? Is the IOPS thing going to be a problem, or is it not going to be a problem? You want to know everything you can about what's going to happen before you go do this in production. So just like any other change, any other thing that you do, you should test it. So if you do all that stuff, you're going to ask the question, well, you said trace at the right level. What does trace at the right level mean? And fundamentally, it means if you don't have time to think about it, then use this one. Use wait equal true, bind equal false, and plan stat equal first execution. Now, this is the syntax for the new alter session, alter system command that you can use ever since 11.2, I believe it was. So the wait and bind are plural if you use dbms monitor dot whatever, session trace enable, database trace enable, serve mod act trace enable. But wait's true, binds false, plan stat first execution. If you do it wrong, if you use the wrong level, it can get you into big trouble. And I've got a story for that. Now, those of you who've watched me present before may remember that I told this story about a year ago. This is an example from the Mastering Local Trace Data book on page 67. And it talks about a batch job that's too slow. This is a lot of text to read. But basically, with tracing off, it's very quick. And with tracing, well, not very quick, but kind of quick. And with tracing turned on, it slowed way down. And I'll recap it here on this simplifying slide. So the problem is with bind equal false, we were getting 122 milliseconds per row of time consumption. But when we turned bind equal true for the trace, it was nearly 3,000 microseconds per row. And if you do the arithmetic, that's a 95.8% overhead or a 24 times penalty for having binds true tracing turned on. Now, if you're tracing for the first time and you use bind equal true, then people are going to say, I am never going to do that again. That worsened my performance by a factor of 24. And people would have a right to think that. But what I want you to understand is that there's a very easy to understand reason for what has happened here. And there's an easy way to avoid it from ever happening to you. And that's the point of my showing it. So really what caused this 24 times performance degradation is three factors. Number one is that for however many placeholders there are, when you use bind equal true, Oracle is going to write 5 times that number of placeholders plus 1 lines per exec call. So for every execution of an insert or an update, for example, let's imagine that the insert or update has 100 placeholders in it, 100 bind variable positions, where um, column 1 is equal to colon A, and column 2 equals colon B, and all those colon A, B, C, D, there's, say, 100 of them. Well, what's going to happen is that Oracle's going to write to the trace data 5 times 100 plus 1 line, 501 lines every time there's an execute of that SQL statement. Now, Oracle does something that's inefficient for the sake of portability. It's just how Oracle's implemented, but the database makes 2 write calls for every line that gets pushed to the trace data. So the number of write calls will be 2 times 5n plus 1. So if you have 100, if you have placeholders, then every execution is going to have 501 times 2, 1,004 writes. And that's just for one execution. And you can start to see where this horrible degradation comes from, because the application that this happened in makes too many exec calls because it only processes 1 row per exec. And that in itself is a performance problem for the application. So the solution here is just trace with wait equal true and bind equal false. When you do that, you'll find out that the application makes way too many exec calls. But using bind equal false will cause Oracle not to print the 1,004 lines for every time the execution takes place, but you'll be able to see the problem with the application, the 1 row per exec problem. Then you fix the application to process sets, not rows. And now the application's faster, and now the application is traceable with bind equal true. And if you use bind equal true now, you're not going to have the horrific measurement intrusion overhead, because now you don't have the horrific number of execute calls. So bottom line, don't use bind equal true until you know it's safe. Use bind equal false to find out. Now, similarly, there's the same kind of an issue with plan stat, and this is all detailed in the book. I won't go through it in detail here, but I'll just say, imagine you have a 1,000-line long execution plan. You've got a really complicated SQL statement, and you've got hundreds and hundreds of lines of execution plan. Well, if you set plan stat to all executions, then every time in a row-by-row application, there's a row inserted or updated, that's going to be an exec call, and that's going to stimulate hundreds of lines of execution plan. You don't want that. So use plan stat equal first execution until you know it's safe to use plan stat equal all executions. And you probably won't need to use plan stat equal all executions. I'm going to come up for a second. Mary Elizabeth, are we good? Do you still have, do we have audio? And are there any questions I need to answer yet?
No questions so far.
I'll take that as good news. I'll assume that means I'm answering the questions with the next slide as we go through the slides. So let's talk now about the fun part. Lesson 2. Why would you want to do this? Why in the world would anybody ever want to trace everything? And the answer is that Ash and AWR are great. Of course, if you're licensed to use them. They really do. The designers of Ash and AWR belong in the Oracle Hall of Fame. And so, by the way, does Tunnel Poder. It's a brilliantly designed set of tools. But there are things that you can do with trace data that you can't do any other way. And it nets out to 2 things. What's so special about tracing? You get call-by-call detail. There is no elision, no sampling, no, oh yeah, during that second some stuff could have happened and we don't know. It's all there. The detail's all there. And the second thing, and this is a killer, you can group by user experience with trace data. Whereas I hate using absolutes like cannot. It is extremely difficult in AWR, and well, AWR doesn't even attempt to do it. In Ash, it's extremely difficult to map what's going on to the things that individual people are feeling. And I'll go into a lot more detail about that as we go through the remainder of the slides. Um, okay, detail and user experience. So what? Well, with tracing, with the detail and with the ability to group by user experience, you can answer 4 vital questions. And those 4 questions are: how long, why? So how long did something take? Why does it take that long? What if we change something? Then what would it take? Then how long would it run? And what else? What else is the question of, okay, I did something and it helped. Now, is there anything else I can do? So it's basically the iterator through this list of 4 questions. What else is basically a go-to how long in this list? And that's a big deal because answering these 4 questions makes you look like magic. Um, the 4 questions are very blunt, very simple to understand what they mean. How long does it take for that invoice report to run? Well, finally, somebody's asking. It used to take 15 minutes. Now it takes 2.5 hours. Why? Oh, utilization during the report is 67%. No, 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 no. That is not an answer to the question, why does this report take an hour now? So what I'm going to do is I'm going to go through some cases that really answer the question, what can you do with trace files? And there's going to be kind of a longish list here. I'm going to end up hitting about, I don't know, 4, probably these 4 pretty heavily. But I want you to see the kinds of things you can do and the kind of effort that it takes to actually do it. And I think I'm 19 minutes in. Hopefully this will take about 20 to 30 minutes. We'll have some time at the end before 3 o'clock to go through any questions that you all have. So I'm going to read these real quick, or at least the highlighted ones. You can see exactly where your time has gone. So when you run a report, you can see exactly why that report took the time that it took. You can predict the impact of a proposed change, and that's going to be the first thing that we look at here in the next slide. This is an extremely valuable skill. It's the skill of being able to say, no, we should not do that SAN upgrade because it's not going to help the report you think it's going to help. The ability to see into the future is the ability to save money and make decisions that cause you not to waste time on things that are inevitably not going to succeed. It allows you to measure and test your systems the way your users feel them. So for example, if you're going to upgrade from 12C to 19C, there are some things that your users are going to be feeling that are going to be different after the upgrade than before. And catching statistics about my database doesn't catch all that stuff. What I want to be able to see is, hey, before the upgrade, booking an order and picking an order took this long. After the upgrade, booking an order and picking an order take that long. And of course, it's an upgrade. You expect it to be better when it's done. Well, sometimes it's not. And the thing is, you can know. We're also going to talk about diagnosing performance problems, even really tricky ones. And I think I have a pretty tricky one to show you. I like the idea of becoming intimate with the performance of your key application functions. Every application function that you have has a breaking point. There's something that can happen that can cause that function to break. Your TV commercial shows up on the Oprah Winfrey show, and every human on the planet buys 10, of your products. Somewhere in the great curve in the sky of how much load you can put on your system will break. And understanding where that can happen is something that you can know by using trace data that you can't know any other way. I'm going to give you an example, and those of you who watched me last time, I don't remember if it was January or another time, but I showed you a Gantt chart of how your workload fits together, and today I'll show you how to do that. And then a couple more things: driving code reviews between developers and DBAs. I mean, how many application functions should have never made it to production, but they did because nobody really looked at it the right way before it got pushed up. And then finally, the last presentation I did, we talked about how to do capacity planning with a couple spreadsheets. So trace data enables all these things. And I'm going to talk about these 4 predominantly today. So number 1, how do you predict the impact of a proposed change? And the first thing I want to do is I want to show you a PYU-Gen profile. PYU-Gen is part of Oracle's payroll application. And we had a client in town, and this happened quite some time ago. We had a client in Dallas that had a problem with payroll. You may have heard me tell this story before. their employees were actually so ticked off about not getting paid on time that they were vandalizing their own employer's property. They were coming in on the weekends and they were tearing up stuff. So payroll was a big problem. And we asked if we could trace part of a payroll run, and this is what we ended up with. It took about half an hour, which is roughly what 1,900 seconds is. So you've already, just by looking at this profile, answered the question, how long was the user experience duration? If we collected the data properly, which we did, then the number on the bottom of this table is going to show you how long the user experience took. And in this case, it was about a half an hour. So the next question we want to ask, remember, how long, why, what if, what else? So question number 2 is why? Why did it take that long? Well, it's easy to see here. We've got 2 things in the list of stuff that took more time than anything else. The SQLNet message from client line took 49.6 seconds. And by the way, Ash doesn't record SQLNet message from client events. It ignores them. So this is one of the details that you're missing if you're only using Ash and AWR. Line 2, you can see, is 21% more of the total response time, and it's SQLNet more data from client. So now we know SQLNet message from client and SQLNet more data from client are where about 70.7% of our response time went. Now, funny story, when I showed the client this table, the DBA kind of looked down at the floor at his shoes and thought, well, dang, this isn't going to help. And the question that we asked back was, whoa, why, this is Technicolor going to help. What makes you think it won't help? He said, well, SQLNet message from client is an idle event, implying there's nothing we can do about that. But the real problem is payroll. Payroll's taking half an hour because it's spending nearly 1,000 seconds doing this thing called SQLNet message from client. It is dominating your response time. And there is absolutely something we can do about it. We have 2 handles on this. If you recall, any performance problem decomposes into one of only 2 things. Either the call count is too big or the mean duration per call is too big. Well, making the call count smaller is going to be a matter of changing the code. And this was an Oracle prepackaged application that doesn't have a bad reputation, by the way. So we didn't think we were going to have to change the code. Normally we attack the call count, but with prepackaged code, sometimes the call count is not a quantity you can easily manipulate. But we looked at this mean duration per call and thought, wow, this is kind of interesting, because the client told us before we got there that the system, the Oracle database was on a Sun Microsystems box back then, and so was the application. And so PYU-Gen should be talking to the database through a fast interconnect that doesn't take nearly 10 milliseconds to complete. And so this number here ended up looking suspicious to us. But I'm getting ahead of myself a little bit, because one of the things I want to do is ask the third question, right? The first question is how long? The second question is why? The third question is what if? What if we change something? And when we came on site, the prevailing theory at the customer site was you've got to fix the latch-free problem, because the latch-free problem is causing payroll to take so long. Now, look at the contribution of latch-free to payroll, and it doesn't make any sense that the client would think that, does it? Because latch-free is only contributing 1.2% of the total time to payroll. If we completely get rid of the so-called idle events like Ash does, and they didn't have Ash back then, by the way, but if the SQLNet message from client events were gone, then we would only have about 600 seconds to work with or to worry about. And 23 divided by 600 is a much bigger percent, but it's certainly not a dominating percent. So what in the world caused these people to think that latch-free had anything to do with the performance of payroll? And the answer is they were using a dashboard. It wasn't OEM. They were using a dashboard that was showing that system-wide, the Oracle timed event, the wait event that was spending the most time, was latch-free. Now, from that, we can infer that I guarantee you they're running a lot of things while payroll is running, because if they were only running payroll, latch-free would not be at the top of their wait event list. But they were apparently running something on the system that was doing a lot of latch acquiring. But fixing that was not going to fix payroll. And that's what drove them into the corner. That's what got them stuck. They thought latch free was a problem. They worked for months trying to get rid of latch free. They even bought an upgrade to their Sun OS box, and that actually made payroll go slower. And the reason for that is because payroll doesn't spend a lot of CPU time to begin with. They had a network IO problem. When they made the CPUs faster, all the other programs that used the network made the network even more congested. So I'm sure these numbers are smaller than they were before the upgrade, but these numbers are bigger because the network congestion is even worse now that people are spending less time between network IO calls because the CPUs are faster. So it fits together like a gigantic puzzle. And the thing we really need to know is, what if I can make the SQLnet message from client thing go better? And what we found was that, yeah, this number is way out of bounds. They were actually connecting this payroll application to the database, which were running on the same machine, through TCP/IP. They had in their tnsnames.ora file their protocol set to TCP, because they didn't realize that the users on the 20th floor could connect through TCP/IP, but the stuff that runs through the concurrent manager on the application server itself, which is on the database server itself, that can actually connect directly through like an IPC or a bequeath protocol adapter. So once we did a little test to show that, hey, look, when you connect this way, here's how long a round trip takes. When you connect that way, it's 55 times faster. So now, after a little test, we know that SQLnet message from client calls can be 55 times faster. And now we can answer the question, what if these calls were 55 times faster? And the answer is that that would drop by a factor of 55. Now I'll do some very rough math here. Well, yeah, I'll do it roughly. Roughly 1,000 divided by roughly 50 is roughly 20, which on the grand scale of things is roughly 0. So basically their 2,000 second long thing is only going to take 1,000 seconds if they fix their protocol adapter and make this number 55 times smaller. And that is in fact what they did. And throughput doubled for payroll. They were happy after having gone and made this change. So this is a story of a problem that didn't get solved for several months, and then a half hour after tracing it, it's problem solved. Now let me do another one for you, because this what if thing is kind of fun. You've seen this one before. If at the Dallas University, I think is where we were at, when I talked with Richard Russell from 7-Eleven at the time. And this is the profile for a 110-second long search for an ingredient in the Oracle product called Agile PLM for Process. So basically what happens here is we've got test chefs in a test kitchen inventing the next sandwich who wants to know, what kind of cheese do we have on inventory? And the query for what kind of cheese do we have on inventory takes about 2 minutes to run, and it's excruciating. You lose your complete train of thought waiting 2 minutes for the answer to a simple question. And it was particularly infuriating to them because they were running this on a $6 million Exadata box. So why in the world does it take 110 seconds? And the answer is, well, because 97 of those seconds is Oracle doing some dynamic sampling. It was a 12.1 feature where Oracle looks for better execution plans every time it runs something. So our question was, well, how much time will we save if we can get rid of this query FRJD8? Well, I hope you can see the answer. The answer is we'll get rid of 97 seconds, almost 98. So if something takes 110 and we get rid of 98, that's going to leave about 12 left over, right? Well, and as it turns out, that's exactly what happens. We ended up with about 12 seconds left over. This statement here went away. You don't see it in the profile anymore. You actually see statements, the blue statements on the left become the red statements on the right. And now the total experience for searching for cheese only takes 12 seconds. So that was a huge win. And all we had to do was turn off the dynamic sampling adaptive optimizer feature that was causing this query to take place for the sessions that were searching for cheese. And of course, in Oracle 12.2, Oracle Corporation makes this much more easily configurable than it was in 12.1. But it had taken 3 vendors, and these are huge vendors: Oracle Corporation, what formerly known as the Big Six consulting firm, and then a big firm from India, were not able to figure out, why is searching for cheese so slow on an Exadata. And months later, we figured it out just by basically tracing once. So 11.6 seconds is a lot better than 110, but what else is an interesting question to ask here? And this is an excerpt from the same report. You'll notice the 11.64 seconds is the same number that I showed here, 647,001. This is section 1.3. What I'm showing now is section 1.1, which explains the same 11.647001 seconds, except this time it's describing the time consumed by database call and operating system call instead of by SQL statement. And what you see here in the text that says your experience duration was dominated by parse calls, these are not all high productivity calls, which indicates an opportunity for performance improvement. So what we've got here is a tool giving us advice that, hey, this shouldn't happen. You shouldn't have parsing show up at the top of your profile. And look at this, 8 of my 12 roughly seconds are spent parsing. Why in the world would an application that's looking for ingredients have to make 881 parse calls? Well, there's another section in the report, section 1.3, which is what I showed a minute ago, except now I'm showing a wider view of it. It's showing us something kind of interesting. These two queries, the two red ones, are being executed 437 times a piece. And by the way, you can tell this is one of those applications where they're generating dynamic SQL in their app, because every single execution is getting a completely distinct SQL text. So what's happening is they're embedding these UUIDs in literal strings in the SQL. And they're executing this thing inside of a loop that runs 437 executions, which is an interesting number because look at the third query, the blue one here. It returns 437 rows. So you can kind of sniff out what's happening in this application, and you can see it linearly, sequentially in the trace data, which there's absolutely no way you could with Ash or AWR. But in the trace data, you can actually see the order in which the SQL statements are executed. And what you could see if you looked is that this statement executes once, which you can see here. It returns 437 rows, and for each row, it runs these two statements in a loop 437 times. Well, knowing that and having the SQL data, the SQL text in the trace data, allowed us to rewrite that application function. Our goal here was, hey, if we can rewrite the app in a morning, and we had that kind of time left over because the contract for our work still had time left on it, but we'd made this thing run in 12 seconds, which was good enough for them at the time. If we could rewrite this and then send the rewrite to Oracle and say, hey guys, we would like for you to rewrite this feature this way, look at how much faster it works and how much more efficient it is if you do that. And we figured that the weight of the client behind that inquiry would actually maybe motivate Oracle to upgrade their product so that searching for an ingredient wasn't so costly. So we did that, took a morning. My colleague Jeff Holt and one of the gentlemen from the client sat down and basically rewrote the search for ingredient application, and they got it running in less than a second. Not a huge surprise. I mean, doing joins in SQL is much more efficient than doing joins in the middle tier. And what we ended up with was a sub-second response time for searching for cheese. And by the way, this was executed on a test machine that wasn't as fast as the production machine that it was eventually going to run on. So I love this example because we're able to answer the question, what if you do this? What if you do that? Is there anything else we could do? What if we did this? Is there anything else we could do? What if we did that? And you can answer the same question, or you can ask the same question after we make this thing run in less than a second. Is there anything else we could do? Is it worth doing anything else? And the only way you can really know if it's worth doing anything else is by asking the question, well, what would it cost and what would we get if we tried something else? But the cool thing is you don't have to spend the money trying it. You can actually predict using the detail and the user experience oriented data that trace data gives you. So that's capability number one. Let's go on to capability number two that I want to talk about. I want to talk about diagnosing performance problems, even really tricky ones. So here's the problem. We had a client that their software actually runs airports. So when you look up and see, oh, my baggage claim is D7 and flight number 1422 goes from Phoenix to LA at 4:13 this afternoon, all that stuff was running in an Oracle database. And this particular airport had about 100,000 transactions per hour. Transaction consisted of an application tier asking the database for some data. And if the database couldn't respond within 5 seconds, then the application would time out. Now, unfortunately, the timeouts are occurring about 10 per hour. That doesn't sound like too bad of a thing because it's 4 nines worth of goodness. But the 10 timeouts per hour were unacceptable because apparently every time there was a timeout, a bag went from going to Boston to go to Austin instead or something. So it was a painful thing for one of these timeouts to occur. And there were 200 timeouts a day in a 24-hour day at the pace of 10 an hour. So it's one of these situations where you've got a whole lot of happy, a little bit of sad, and it's buried in all the happy, and you've got to go find it. So here's what we did. We traced everything at the airport for an hour, and this was an act of politics, right? It took some days between us advising the client to do this and the client actually being willing to. But tracing correctly, we ended up not causing any measurement intrusion that anybody noticed. So the client actually did trace everything for an hour, which resulted in 67 trace files containing about 5 million lines of trace data. In this 5 million lines of trace data, there were 90,000 transactions roughly. There were 5 timeouts. So it was actually a pretty good hour. They didn't have 10, they only had 5. And one transaction they noted lasted 9.5 seconds. I don't know how they knew that. Maybe somebody told them, or maybe somebody actually measured with some other tool, but they knew that one transaction had lasted about 9.5 seconds. And the cool thing is, with the right tools, it only takes about 5 minutes to figure all this out. And I'll show you what we did. So here's step one. This is a standard report in the MethodR Workbench that reads trace data from many files. So literally what I did was I loaded 67 trace files, and then I said, hey, for all 67 files, I want you to report to me the experiences represented in these files. Now, if you're interested in how we define an experience, it is literally the trace data that maps to what a user felt. And we can kind of sniff this out. It's a little bit of, it's just software magic is all it is. We know how to go into a trace file and cut it up into individual user experiences. There's enough data in there that we can kind of know, yeah, this is a unit of work, and then there was a little pause, and here's another unit of work. So it was the most amazing day of my recent career when they gave us this data, because running this report resulted in, look at that, a 9.5 second duration transaction. Now, the way to read this, GXL Aura 131.168.trc is the name of the file where that transaction is. And 145010, we call it the island ID, but it's really just the line number in the trace file where this 9.4 second experience starts. And so knowing that, we have another tool that we can use to cut into the GXL Aura 131.168.trc file. And if we just look at that file, we see the same 9.447 second experience on line 145010. And we also see that in this file, notice on the prior page, this was a query run across a lot of files. And we see that the top 10 experience durations were all in different files. There's no repeat of a file name here that I don't think there's a single repeat. But here, I'm just drilling into the file called 131168. Now, the point I'm trying to make is that inside this file, there are 4,822 different experiences. And I don't care about 4,821 of them. All I care about is this one right here that took 9.44 seconds. Well, with the tool, with MethodR Workbench, it's really just 2 clicks to isolate and then profile the data. Now, you see this number here is not 9.44, it's 9.47. The data that you see in this format is more precise data. It's actually generated by a much more complex tool than the data I showed you on the prior page. So the data on the prior page is good for drilling to know what file to go open. This tool, which is basically our MethodR profiler output, is showing us that that transaction really took about 30 milliseconds different than what the other report showed us, but it took 9.5 seconds roughly. And 8 of that was one roll lock. Now, when we found this problem, the client said, "Oh yeah, we have very little roll locking." You can imagine the AWR report for the hour that they ran this. There was like, you know, thousands and thousands of seconds of work being done, and probably only about 10 or 15 seconds of roll locking in that hour. But the roll lock is what caused this timeout. So this roll lock cost them money, even though it was only 8 seconds. It costs them money. And roll lock is never going to be at the top of the AWR report on a day when it happens because it happens so infrequently. But again, they had a 99.99% success rate with their transactions, but that wasn't good enough. What they needed was to find out what's causing these timeouts so they could eliminate them. And this is literally, if I were to receive these trace files now, I could tell you this within the first 5 minutes. So it actually takes less than 5 minutes to tell the story in detail. If you're interested, hit this QR code and you'll go get to watch a YouTube video that's, I think, 4 minutes and 57 seconds long that shows what clicks and how to do this with the product and the whole detail behind it. I didn't want to spend time doing that today because I've got more stories to tell. So that's a pesky intermittent problem that is easy to solve with trace data. Now, another thing that I mentioned to you, and I did talk about this at a prior Doug meeting. I don't remember when, but I think it was the most recent one that I did, was how to draw a Gantt chart of how your workload fits together. And I'll show you a quick picture. This is a nightly batch executed by the large company that I told you that traces 6-hour chunks of their whole database. So they actually traced their nightly batch job. Their problem was that their nightly batch job was starting to creep and run longer and longer and longer. And it was starting to violate the window that it was supposed to run in, which is a big deal because at 8 o'clock in the morning, all the nightly batch is supposed to be finished so that the businesses that use this application can open and get to their data. The problem is when the nightly batch runs past 8 o'clock in the morning, their customers can't open for business using the app. And in fact, they've got a service level agreement, which requires that they pay their customer a penalty. So it's a big deal that this application was spending too long every night running its stuff. So we actually got them to trace the whole entire nightly batch job. And it came to our attention that they actually motivated the question that we could draw a Gantt chart using the trace data, because all we need, and I'll show you this little sticky note here, all we need are the start times and durations of all of the trace files. And then what we can do, if we've got the name of the trace file, the start time, and the duration, we can plot a stacked bar chart. So each of these bars is actually a stack. The bar on the left is invisible, and the bar on the right is blue. The height of the invisible bar is the start time, and the height of the blue bar is the duration. So what we've got is basically a bar that offsets the beginning of the blue bar, and then the blue bar shows when the start time was and when the end time was, and of course the length here is the duration. And it took me probably half hour's worth of fiddling in Excel to get this one done, but it's a really, really cool tool because once you have this, you can start looking and say, okay, there's a lot of stuff that runs in parallel. Wow, this looks like it's doing a lot of work. What's going on? And you might look at that trace file. And by the way, you can hover over a bar and see the name of the trace file in addition to the duration and so forth. And you can see things like, okay, this bar right here, it was obviously doing something and it had to get this far before that thing could start. It looks like this bar is open for the entire duration. So if you open the trace file, you might see something like, yeah, it does a little bit of work at the beginning of the trace file, and then it waits on a big SQLnet message from client for 3 hours, 6 hours maybe. So you can see all that stuff. And you can see things like, all right, there's a lot of work being done here in parallel, lots of sessions executing all at the same time. But down here, there's a weird thing. There's a gap. There's a huge gap between the end of that file running and the beginning of whatever this file recorded was running. And if you open this trace file, you can see the last SQL statement. And if you open that trace file, you can see the first SQL statement. And you can say, hey, dear client, I don't know what's going on, but there's a gap between when this statement here finishes and when that statement there starts. What's going on in the application when that happens? And what happened here was miraculous. The client actually was able to go, oh yeah, right after that statement runs, the application does this thing. And I've always wondered how long that took. But yeah, that the application is what's taking so long. It's not the database at all. It's stuff that's happening between database calls. And they were able to actually go to their application, which was an SAP product, and tune it. There are all sorts of tunable parameters in this application that has nothing to do with the Oracle database. And they were actually able to make these gaps shrink down so that the time between here and here went away. And so it compressed the timeline. They did this enough. They worked on it for about a week or two, and they got this thing running in something like 3 or 4 hours. I mean, it was finishing at like 4 in the morning by the time they got done. And they really didn't have an Oracle database problem, but the trace files helped out anyway, because it showed us where in the flow of their overall workload, their performance was, or their time was being wasted. So it was a really cool engagement for us, because trace data to the rescue. I'm coming up on the schedule that I set for myself. I wanted to have about 10 minutes left over for questions and answers. It looks like we might hit that. So let me start the recap here. And I'll say this, even if you don't need to trace everything, and you might, but even if you don't, knowing that you could is kind of a superpower, because there's all sorts of stuff you can know with trace data that you can't know any other way. And I'll go back to the slide that I showed you before. What can you do with trace files? Well, you can see exactly where your time has gone, right? The PYU-Gen thing was a surprise because people thought time was going to latch free, but that was just a system-wide aggregator tool saying, hey, on your system, a lot of things are using latch free. Payroll happened not to be, but the tool didn't bother to tell them that. Trace data does. You can predict things. What if I buy this SAN? Well, it's going to make IOs go faster. Well, how much does this program use IO? Because if it doesn't use IO very much, then the new SAN's not going to help this program very much. If this program is the whole reason I'm buying the SAN, then no, I don't want to buy the SAN. Well, what does this program do? Well, it does a lot of network IO. Okay, is there any way we can attack that, right? Predicting the impact of a proposed change keeps you out of the doghouse. It keeps you from making expensive decisions where you're just hoping it works, and then you find out later whether it does or not. You should be able to predict these things before you spend money on them. It allows you to measure and test what your users feel. So testing becomes different. Yeah, I know that running RAT, for example, real application testing, is awesome. I can run some workload, and then I can play it back later, and I can run AWR on both sides. But you know what, guys? AWR doesn't always give you what you need to know, because what you need to know is, if I do this thing that I'm thinking of, upgrading from this version to that version, moving from this platform to that platform, etc. If I do that thing, is posting going to take longer? Is booking an order going to take longer? Is invoicing going to take longer? Is PYU-Gen going to take longer? Well, those are the things that you can measure in detail before the upgrade and after in your test environment, and you can know. So you don't get hung up with surprise degradations that you never saw coming. You can diagnose performance problems, even really tricky ones. I think I've shown a good example of that. Becoming intimate with the performance of your stuff. It's huge. You should know what the next thing that's going to break is, and you should have an idea of what has to happen in order for that to break. And we talked about the capacity planning spreadsheet last time I talked. This is data that you can feed that. Draw a Gantt chart of how your workload fits together. I've shown that. I haven't talked about this really, but driving code reviews between developers and DBAs is so important, because developers speak the language of how long does my thing take to run, and developers can also appreciate code path. And basically, trace data is a trace of the code path that's happening inside the database while the application developer's code runs. An application developer doesn't have to be an Oracle expert to be able to look at a profile and see, hey, I know this pattern. This is the one where I parse too much. I'm sticking literal SQL in my code, and this is what it costs. Right? There's probably a half a dozen patterns that once you teach your developers what those patterns are, they can solve their own performance problems without ever bringing them to your production system. And then finally, plan how much capacity you'll need, which I've mentioned a couple of times. So a few of these I covered in some detail, a few that I didn't. You can see more detail. Each of these little pictures represents a 2-page front and back monograph. Number 1 was called Solving the Unsolvable Performance Problem. Number 2 is called Preventing the Post-Production Performance Problem. Very alliterative, I might say. Number 3 is called Better Testing, Better Risk Reduction. And number 4, which I haven't released yet, but I'm hoping to build some anticipation for it, is called Death to the Health Check. Long live the health check. That always confused me when I was a kid. What does it mean? Death, the king is dead, long live the king. Well, it's a different king in the first half of the sentence than it is in the last half. So that's the same with this paper here. So I'll leave you with my business card. Again, hit this QR code if you want to go to the methodr.com site. Send me mail either at cary.millsap@methodr.com or info@methodr.com. They all get to me one way or the other. And please, if you're interested in this at all, and if you want to get your hands on the tools where you can do this kind of stuff for yourself, contact me. I'll put you in touch with the folks at Centra that will set you up in this 90-day kind of COVID-19 program where we're trying to just get people, give them a shot at something that they might not have had a shot at any other way. With that, Mary Elizabeth, I guess we've got about 7 minutes left. If there are any questions or discussions that you want to have, I'm ready to take a breath.
All right. Well, very good. Thank you. Thank you, Cary.
My pleasure.
So everyone, if you have questions, please send them either to me privately via chat or to everyone via chat. In the meantime, I had meant to read Cary's bio at the beginning of the presentation, but I'm going to read it now because I'm going to read everybody else's and so you too. So Cary Millsap is an entrepreneur, writer, teacher, designer, developer, consultant, and software performance specialist. He has presented at hundreds of events around the world, and his innovations and teaching have influenced thousands of Oracle professionals. Mr. Millsap is the owner and president of Method R Corporation. He's the author of the Method R Guide to Mastering Oracle Trace Data, 3rd edition, and the lead designer of the Method R Workbench software suite. He wrote the book, Optimizing Oracle Performance, for which he and colleague Jeff Holt were named Oracle Magazine's 2004 Author of the Year. He's published in the professional journals, including Communications at ACM. Thank you, Cary, for being here.
So, I sound lovely. Thank you for that.
Well, you wrote it. I just read it.
Yeah, but I sound lovely.
Yes, you do. That's because you're a badass. So we have 2 questions so far. The first question is, does Method R have anything like ADDM that provides recommendations based on your problem diagnosis, based on your decades of tuning expertise? That's a long question. Do you want me to read it again?
No, I got you. We sure do. You might have noticed, and I went through so fast and the print's so small that maybe you didn't, but every one of these tables that I show has a paragraph in front of it, and the paragraph's generated by our software. And this one here, for example, it says this experience executed 19 statements, which jives with that number there. Note that Mr. Prof aggregates into a single statement all similar but unshareable statements. It could have used placeholders but didn't. No single statement consumed a significant portion of the total duration. To make an impact of 20% or more, you're going to have to execute remedy actions that will affect at least 2 statements. So it says stuff like that. That's not the particularly most helpful one that I could have chosen, but let's see. This is a good example. Your experience duration was dominated by this thing and it shouldn't have been. So as you go, if you read in our standard default product, we have this feature called the advisory text. And we're getting ready to release. We had planned to release before now, but we kind of didn't want to do the big celebratory, oh, we're so happy and we're so proud of our thing. And, people are ill and family members are struggling against this pandemic. So out of kind of respect for the situation that we're in, we haven't released Workbench 9, but one of the things that we've really spent a lot of time in the new release of the product is tuning up and making sure that these advisories are accurate and helpful. So you can see things here, just one statement consumed 88.6% of the duration. Click that statement to determine where it spent your time. And in the HTML document, when you click here, you go to another place that has more paragraphs that say things like, oh my gosh, you're doing way too much parsing here. Stop it. If you stop the parsing, you're going to save this much time, that kind of stuff. So yes, is the short answer to that question.
All right, very good. Another question we have is, what is the process for signing up for the class?
Send me a note. Either, let me go back to the top of this thing, either Cary Millsap at methodr.com or info@methodr.com. And I will make the right introduction for you. It's all very new. We haven't started yet, but I think we're planning to have the first session on May the 17th, I think, which is 10 days from now. And so Sintra is in the process, and I'm helping, of course, in the process of gathering up students for it. So send me a note. I'll make the appropriate introductions with the guys at Sintra. As soon as the registration ID is available, we'll let you know, and you'll be in.
Okay, very good. And we have another question. I can either read it or the group can go to chat and read it. It's really long. Did you see that,
I'm
Cary?
looking at it. Yeah,
okay.
I'm looking at it. Let me actually, I'll read it. Oh, it's from Jared, so it's bound to be good. He says, okay, so in your last example, you were able to show the break where there was no Oracle activity that indicated the app server was responsible. Apparently, the customer knew about the potential for specific app activity that would take excessive time. For customers that don't know, is there a way to synchronize the time on the database server with that on the app server and the MethodR tools? Then you could easily match diagnostic data from Oracle and the app. That's a really good question. What we did, and I think by last thing, I'm gonna go out of Keynote here for a second, and I believe it's this page here that he's talking about. Yeah, so I think what he's saying is, what if the time on the database server were slightly off? Some kind of like NTP not enabled, so that we don't have synchronization between the app server and the database server in times. Then something that looks in the database like this gap happened, it looks like sometime between 43 past midnight and 126. But if we look at the actual data, we can see to the millisecond, actually to the microsecond, what time Oracle measured this file starting at and ending at, right? This file here started at a millisecond time, and we can know that value from the workbench. The workbench will go calculate that for you. So it's a pretty good clue, even if the two clocks are off by, God forbid, like as much as a second or something, because we can go look at the trace file and see the SQL text itself. We can tell the client that, yeah, after this happens, before that happens, what happens? And this isn't a DBA question, right? This is a question you got to ask the user of the application. And typically with an application like this, it's SAP Data Services. You're going to have like analytics people who are deep into how to use this tool. And when they know what data just got gotten, and they know what data is going to get gotten next, it kind of puts their mind in, oh, I know exactly where in the app that's going to be happening. So it's not a DBA thing, it's an application expertise thing. And sometimes, man, I mean, if that's where the problem is, then that's what you're going to have to go learn. In this particular case, the client didn't have to really learn anything because they sort of knew. In fact, the guy that was able to fix this had a suspicion that this was a problem, but it's one of those things that was on his to-do list, but it was like 35th on his to-do list. He didn't realize how important it would be to do it now. So in this case, then measuring just told the guy, yeah, that thing you were going to do anyway, you kind of need to do that now, because that really is like your number one problem with this application. Now, if that person hadn't existed, then all of a sudden we're talking to the vendor. We're probably getting the client trained in, oh yeah, that the way you're using the product isn't very optimal. You can cache this, you can rewrite that, you can reconfigure this, you can change the parameter for that. So in our case, we were fortunate because the client was an expert in using this third-party tool that we identified how much it was costing.
All righty. And Cary, as Chris and I are talking about in the background here, I believe you had a 5-minute case study video that you had wanted to play, but you weren't sure if you would have time. I don't any further questions. Did you want to play it, or did you want Chris to play it?
If you can work out how to make the audio happen, because the only thing I can do if I play it, it's going to be audio into the mic off the laptop, which is probably not going to be a great high quality experience. So I'd love to, but I'm not really sure that we'll be able to do a quality job of it technically using Zoom or any other technology for that matter. I don't know how to show it, but this is the if you hit this QR code with your phone, you'll go right to the article. I can also show you. Let me drag a browser window down here, and I'll show you something real quick. I'll show you how to find it. So let's do this. I'll need to go to methodr.com. Whoops. And then basically any page you land at, if you scroll all the way to the bottom, you'll get to this black zone, kind of the standard WordPress where you put your contact me and all that kind of stuff. The recent post called MethodR Workbench, the pesky intermittent performance problem, that's the link. So if you click that, you get to the YouTube video and then you can play it. I really wish I knew how to jack in the sound. Maybe it's some kind of Soundflower thing or something, because I frequently wanted to play videos through Zoom sessions, but I just don't know how.
Okay. Well, to everyone in the meeting, the facilitator, who by the way is Chris Frost, the Doug president, and this meeting would not be running smoothly at all without him, so thank you, Chris, has posted the article and the video, the link to it.
Perfect.
You can watch that at your leisure. Last chance here. Does anybody else have any questions for Cary? A few more seconds. I'm going to say to let last-minute stragglers come in, but we don't want to call our esteemed attendees stragglers, so I'll try to think of a better word.
Well, hey, folks. Thanks very much for the opportunity to spend time with your audience. I really appreciate it.
Okay, I don't believe we have any further questions. So our next speaker will be at 3:30. So so let's go ahead and take a break until then. And Cary, thank you so much. As always, this has been an excellent presentation. I say this every time like a broken record, but you've brought common sense to our presentations. And it's not that other people don't talk common sense, but other people talk about products. That's important too, but I like to loop back yearly and have you here and hear about common sense. So thank you so much. My pleasure, Mary Elizabeth. Thank you again for inviting me. All righty. We will see all you kiddos back at 3:30 when Liron Amitsi will talk about optimizer issues. Thanks.
Thank you.